Hi guys, you're welcome to my channel. Today we want to look at a question on equilibrium of forces. This question was suggested by a subscriber. Okay, and we are going to look at the solution in detail. How do we go about this? The question tells a uniform meter rule AB of weight 0.08 Newton has a 1.0 Newton weight hanging from 10 centimeter mark. Determine the balance point of the meter rule. Okay, how do we go about this? Don't stress yourself, but I would like you to understand some fact. If you have a meter rule, a uniform meter rule, note that if the meter rule is actually uniform, like the question states, the weight of the meter rule is going to be at its center of gravity. That is, the center of gravity of that meter rule is going to be 50 centimeters. And that is where we are going to have the weight hanging, which is 0.08 Newton. Understand that first. I'll take it again. For a meter rule, if the meter rule is actually uniform, just like the question states, its center of gravity is going to be 50 centimeters. Since the actual length of a meter rule is 100 centimeters. Do we get this now? Cool. But if the meter rule is not uniform, just like the one we used to have in the laboratory at times, their center of gravity is not always 50 centimeters. At times you can find it 48, at times you can find it 49. But because the question states that it's uniform, then the center of gravity is 50 centimeters. Then the weight of it is going to be at that point. Then we are told that a weight of 1.0 Newton is hung at 10 centimeter mark. That is, from here to this point, where we have a weight of 1.0 Newton, is a distance of 10 centimeters. Now, at what point are we going to place our pivot so that this body can balance? If you are going to solve this question successfully, I would like you to ignore moment in this case. Don't consider moment. The balancing point of a body is its center of mass. Therefore, calculate for center of mass of this body instead of you calculating for the balancing point. When you get the center of mass is the balancing point. So don't bother thinking about taking moment, because you don't know where to place your pivot. And if you decide to place it anywhere, you might not be sure of your result, of which it might make something difficult. So why can't you just do it in a simple way? Okay, let's do it simple, guys. Okay, we know that this is horizontal axis, so the center of mass in centimeter is going to be the product of the weight 1 multiplied by distance x1 plus weight 2 multiplied by distance x2 divided by the weight 1 plus weight 2. This will be very, very cool. It's quite awesome. Physics is not difficult. Remember, it's all about you understanding the concept. Cool. This is then equal, our weight 1 is 1 Newton, that's 1.0, multiplied by our x1, the distance from 0 to where we have our weight 1 is 10, so we have this to multiply by 10, plus our weight 2, which is 0.08. The distance of this weight 2 from the origin is 50, so we multiply this by 50, divided by 1 plus 0.08. Cool. So, our center of mass is going to be 10 plus 50 multiplied by 0.08, 0.08 multiplied by 50. That will give us 4. So, this is 4. Okay? Divided by 1.08. So, this will become 14 divided by 1.08. And what will be our result? 14 divided by 1.08. So this will give us 12.96. So our center of mass is 12.96 centimeter. I don't want to approximate to 13. Why? Because I'm dealing with this question practically. Is that taken now? Now let's confirm if my result is actually true. So if I place my pivot at 12.96, that is from here to this place, from here to this place is 12.96. That's actually the right answer to the question, but we want to confirm if that answer is actually correct. Okay, let's quickly look into that. So if from here to this place is my balancing point, so the distance between here, between this and this is just going to become 2.96, while the distance between the center of gravity and this is going to be 12.96 minus 50. What are we going to have? So this will give us 37.04. Remember, this diagram is not drawn to scale. Cool. So we can now take our moments now. Taking moments about the pivot. We are taking moment about the pivot. So we have 1 multiplied by 2.96. If this is actually at equilibrium, then this must equal to 0.08 multiplied by 37.04. Okay, this will just give us 2.96 Newton centimeter, right? So this is going to be Newton centimeter, and 0.08 multiplied by 37.0, so absolutely 2.96. Okay, so this is quite awesome, and that is just your result to that particular question. So I will urge you to just love physics and just understand the concept of physics. Do have a nice day. If you have any question that you like to suggest to me, kindly make use of this channel, Privilege Academy 2014 at gmail.com. So you can just forward your question to that mail. I will pick and I'm going to come here to put down the solution, the one that I can do. Do have a nice day, guys. Don't forget to subscribe to this channel, like this video, share with your friends and family. Have a nice day.